Last week I took a look at the motors and the mounting hardware, trying to figure out what was wrong with them and getting that kind of set straight. This week I've been taking a look at the batteries and the power system, trying to figure out the best way of moving forwards and kind of getting that running a lot better than it once was. So originally, Kevin, the robotic platform here, was designed to run from these 12 volt sealed lead acid batteries. They're pretty beefy kind of things, and they did the job. They actually worked really quite well. But they're a little kind of bulky, they're a pain in the ass to charge, so I'm kind of trying to go for a slightly a better system. As I mentioned last time, I'm going to switch out for Lipo batteries. And so as a kind of test, just to see what we've got to work with, I picked up one of these batteries here. Now the big difference is the voltage that it runs on. These are 12 volt batteries and they ran in series, or kind of pairs them in series to give 24 volts. And the whole system ran on a fixed kind of 24 volt supply. Lipo batteries aren't quite as clean in their voltage ratings, kind of work in multiples, I think at 3.7. So the nearest I can get was, I think, 22.2 volts, which is more than enough for the motors, but it will mean some reasonable changes to some of the power monitoring systems to make it think that that is an acceptable voltage. So this box here is the main kind of incoming power distribution setup place. And so that's where all the batteries kind of, batteries feed into here, and then power then comes out of here to the other systems. And it's where kind of the main on-off switch goes, and is where kind of power cables get split out. So if I open up the box here, it's a little bit messy at the moment, but I'm making use of a pretty hefty 100 amp three-phase switch here, just to switch ground and neutral. And so the batteries kind of come into this bank here. It's kind of set up to accommodate kind of 4 incoming supplies that will kind of get merged into one single feed here. This power then comes out of here through a current monitoring sensor. That data feeds back to the Arduino, and then that feeds out to a fuse box here. Power then gets distributed from this point outwards. But the problem I've got at the moment is power sensing. And so this bit over here especially, this is like a really crude just LED bar display, just showing kind of the voltage rating. But it's kind of hard coded at 24 volts. There's no way to change that, and so this unfortunately has to go. So I'm going to have to kind of scrap that and get rid of it. This thing can be reprogrammed to kind of update to the new voltage levels, which I'm going to do. But the problem is there's no obvious indicator that the battery level is getting low. So the red lights here are actually quite useful. So what I'm going to do is fit another kind of indicator light fed from the Arduino, which will kind of tell me when the battery level is getting kind of dangerously low. I've removed the old board, kind of stripped that out. This is kind of one of those kind of kit module things. You can buy kind of a fully completed thing. I mean, it actually works quite well, but not really relevant for this anymore. So what I've done on the back here, apart from removing that, I've soldered on basically a NeoPixel to my WS2812 RGB LED onto one of the spare ports in the Arduino. It is rather hideous, the connection, but it was pretty straightforward and it worked quite well. I've modified the program now to output a colour, kind of red, yellow, green, depending on the status level. The OLED screen on the front originally had, or still has, 3 status levels, kind of OK, warning, error, depending on kind of voltage and temperature readings. And so this is basically tied into that. So these ports in the front will need to be blocked off and like a single light mounted through, like so. If I do a quick turn on, you'll see the system in action. As it boots, the light sequences through red, yellow and green just to confirm that the light's kind of set up correctly. And then as the battery level kind of gets monitored, it switches to green, and that kind of matches with the OK on the screen. This is all to be stripped out, but back when I was using these lead acid batteries, I came up with what I thought was quite a clever mounting system for them. And so the difficulty was, do you kind of go overkill and make some kind of casing or mounting point? So what I did was built these kind of trays for the batteries to sit in, and then I'm using bungee cord across the top. And so this means that the batteries can be very easily kind of added and removed, and it provides a pretty decent amount of support. It uses these 3D printed clips to kind of just grip the batteries. It gives you a really good connection. So one thing that needs to be decided, or at least considered in this case, are the actual the specifics for the batteries. I know I'm switching these out for these, but it's a case of how many and what type of battery. These are 12 volt 13 amp hour batteries. They're meant to work in pairs, so it's 24 volts 13 amp hours, and it's originally designed to accommodate 4 banks. That's kind of over 50 amp hours of power, and I'm fairly sure this runs at about 20 amps when kind of full power, so that's over 2 hours of runtime, which is really quite good, I think, for something like this. Unfortunately, something like this is only 3 amp hours and it might give me 10 minutes, 15 minutes kind of runtime, which not really acceptable. So I need to decide if I'm going to get bulkier packs, so 10 amp hour or more, or maybe accommodate multiple smaller packs. And so that's something I've got to kind of decide. I think I'm going to go for and try and keep it as flexible as possible. So maybe a few connectors so I can plug in a handful of matching pairs maybe, or just one pack, depending on what I'm doing at the time. So the other change I'm going to need to make here is to remove this battery support system. It is a bunch of angle iron welded in place, but it's designed explicitly for these the original lead acid batteries. So I think to keep it, it's just going to get in the way. And so I'm going to try and cut this out and kind of free up some space. The battery box has been removed. The tray is kind of completely out. I still have the corners left to remove, but I'm going to do that when I've got a better kind of cutting disc to kind of clean that up a little bit. But it's given me a lot more space. I think the first thing I'm going to do is shift the kind of power distribution box back a little bit. It's always really awkward with the overhanging edge here. That should certainly help things a bit. The next step will then be to kind of sort out a battery mounting plate of some kind. So that'll be the kind of plan for this week. Try and figure out how batteries can mount and come up with something to kind of safely hold them.